Hey there, I'm Bill Warner with EntreDot, and this is Monday Night Live on Facebook. And tonight, I'd like to talk about software development. I'm an age-old software development guy, so I ought to be able to handle this. But in this modern world, so much has changed, but yet there's a bunch of things that haven't. The purpose of this, though, is not to embroil you in all the details of the tools and the options for development platforms and things like that. I'm trying to address this to small business owners, the CEOs of them, the CTO if they have one, the person in charge of development, and maybe even software development team leaders, particularly of new businesses. So I'm going to go over really a characterization of the many kinds of things that have to be part of a software development plan, the kinds of things you've got to think about. So if you're a senior software developer, you're going to find this rather rudimentary. If you're a small business owner, or you're just starting out with a software company, you might appreciate this. So I'm going to get on with it now. So also the scope of this is to really address most kinds of software applications you see today. Phone applications would apply here, host-based applications, middleware software projects, web applications as well, many of which are paired up with a phone app, quite frankly. Split the load, if you will, in handling the customer requirements. So there isn't a software type, application type that doesn't apply here. So what I'd like to go through now then is the various steps in software process and the planning for a software development project. So at the beginning of all of this is an understanding of the customer requirements. That's pretty basic. You might not even think of this as part of software development. But you don't have a product unless you've got clearly understood customer requirements. Now you might ask, well, didn't the marketing guys take care of that and market definition and things like that? Well, I said, of course they did. But there's a level of detail that the development team has got to know, and there's got to be significant clarity about what these requirements are. But it starts with an understanding of the needs of the customer. You've heard me talk about this many times. So let's understand the opportunity, the needs of the customer, the problem they have, however you want to put it, and what your solution is. But this goes deeper in terms of these functional requirements. Things that this software has to do to address these needs have to be spelled out. Other things that have to be known as what platforms are the ones upon which this software has to be delivered. I'm thinking of operating system platforms and computers that they run on. And the usual haunts are Mac OS and Microsoft Windows and maybe Unix, or the forms of Unix that exist today, server-based platforms, in other words. There's got to be some understanding of how the customer would be interacting with this software. So it gets the start of the usability and the functionality of the user interaction. So the manner in which this software is going to be deployed. Is it all on the phone? Is it phone and a server, or a cloud-based application, and that's all there is to it? So these kinds of things have to be talked about from the very beginning. And yes, a lot of it came from your business plan that you hopefully wrote before you started all of this, and your market survey that you did, or market surveys, probably, plural, the interviews you've done with potential customers, all of which lead you to an understanding of how this product is going to serve their needs and how it's going to appear to the customer. Okay, that's customer requirements. Then the technical guys got to get to work here a little bit, and that is define the architecture for this software. Here's what I mean by that. I already mentioned the word, well, what platforms is it going to run on? Which operating systems is it going to have to be running on those platforms? What is the split of functionality between, they say, the cloud-based server and the phone app? Because you're going to have certainly a user interface on the telephone, perhaps, maybe some processing there with back-end databases. All of that kind of stuff. You've heard the term back-end and front-end. So the front-end being the way it appears to the user. The back-end is where all the information is kept and processing occurs and things like that. So the basic layout, we draw pictures of this, of the architecture of this software product and how its functionality is distributed across one or more platforms. Okay, then you go deeper, you get into the design of this product. And it starts with a document that you would think is necessary. I call it a functional specification. It's a detailed document that spells out all of the functionality of this piece of software. It's called a functional spec. So it deals with the interactions with the user. Every single function is described in considerable depth of what it does, how it does it, what are the inputs to it, and what is for each one of these functions, what does it provide that is part of this whole suite of functions that you're delivering to the customer. What does output look like? So you've heard of input, process, output. Well, that's kind of the way I'm thinking about this, but it's all about the functionality, one by one. Every single function, without a doubt. Then the user interface has special design considerations of how this functionality will literally appear on the phone screen and on the glass on the computer, and how does the interaction occur? What you typically see at this design phase is wireframe rendering of screens that would be literally appear, and maybe a sequence of them as the functionality progresses through various steps. So you can imagine a series of screenshots that are describing the user interface as it relates to each one of these functions. So you can see that you're getting all of the internal functionality, how the functionality is distributed across platforms, and how it appears to the user. The person actually typing or punching keys on the phone or whatever. So a functional spec, user interface design, and then getting into the details of the internal structure of the software itself. The various modules. This takes high-level designers, seriously trained and experienced software developers who lay out the actual software structure, naming all of the modules, how they relate to each other, module being a bunch of software instructions that has an API to it, or interface to it, however you want to put it, with known inputs to it, and it produces something at the end of it. It finds a record, if that's what its function was. It does a calculation. It sets registers or sets pointers or sets values based upon some calculation that it does. A module does a lot of things. So laying out all these functions in a diagram showing the relationship of them all, and the interfaces to them and the outputs from them. So you now have a high-level design in considerable detail from which you can start coding. Better yet, the team leader can start structuring the team and assigning out these various modules to be developed. Now, the developers themselves, the coders, if you will, people writing code, which could be the team leader included in that, is going to assign various modules out to various people based upon their skills, their abilities, their know-how. It's a pretty complicated planning task that the software team leader has. But now we've gotten through design. The next thing, well, let's start writing some code, right? So the coding phase is done as a team, in a team structure. They have a process. You should name the process. So this coding phase, it's part of the plan, that is. You're going to describe the tools that you're going to use. That's languages, databases, things like that. You're going to assign roles and responsibilities to team members. So you have a well understood breakdown of the workload across a number of people on the team. The languages that you're going to be using are also selected, of course. Doesn't mean that, leave that out. When it comes to database selection, you're going to deal with the manner of access, how it's going to be secured, what are the tools going to be used and incorporated in some cases, what reports are going to be necessary to manage the database structure, and the list goes on. When the languages are selected, the things you're going to be thinking about is portability across multiple platforms, the age-old Windows versus the other platforms on telephones, and software operating systems. So the portability of code is an important thing because you don't like to have to write this stuff twice, but unfortunately you often do. Or if you do get portability, it's not totally 100% portable. You've got modifications you got to do for other platforms other than the main ones. So you're going to also have management tools to track the progress of the development. There are plenty on the market. Slack is the one that comes to mind now. I know a lot of teams use it, but there are dozens and dozens of others. Pick one. And whatever process you choose, if it's an agile process, which is fine, or some waterfall thing that everybody thinks is ancient but isn't, at least in my opinion. How you're going to secure the source code, it's got to be considered. How you protect it from others that shouldn't be seeing it or ever have access to it, stuff like that. These are all things you have to consider in the coding phase. Okay, so now you've written some code and substantial amounts of it. We got to think about, well, how are we going to test this nightmare? So testing itself is divvied up across a number of people. So I'm going to talk about unit test, function test, system test, and beta, and then a couple others on the side. A unit test is done by the individual developer. They're testing some grouping of these modules. Perhaps you've been assigned 5 to 10. They're all related to each other. They have defined APIs and outputs, and you're going to run these modules. They're not performing any function other than what they do on behalf of the product. And you're going to make sure that all the paths of the code have been run through, and that given the parameters that are presented via the API, produce the right answer coming out the end of it. And you do that for every path and every combination of API functions that are going to be used for this grouping of modules. Every developer does this. Then the team, someone on the team, pulls these modules together into a functional system and performs some form of function testing. Function testing is, hey, remember the specification we talked about earlier? Well, those are all the functions that have to work. So a test plan is put together to test all these functions that when the end user which will be someone at the customer's company, enters certain information or makes some request through the user interface, that the right things come out in terms of presentation as a result of that, of a request. So this function test is of all the software put together, or maybe phases of the software, but complete function exists within this now larger group of modules that can be tested functionally, that you're performing the functions of the functional spec. The purpose of this test is to prove that this software actually produces these functions correctly. Simple, huh? Then, once you've gone through all these functional tests, maybe they're done at different points in times, but once you got all the software, you bring it together for what I call a system test. In some companies, if you have a large enough development organization, have quality assurance teams that do this kind of thing. So it's put into the hands of professional testers who quite literally run this thing ragged. They try to break it. They pride themselves on this. They're not trying to be malicious, but they're trying to emulate what the customer would really do, actually the kind of mistakes they could make, and make them and see how the system reacts. So those are the three forms of testing. Now, this fourth one I mentioned earlier, a beta test. This is an early use of your completed system-tested software actually brought out to a handful or more of real customers that are willing to take your software early before its general availability and actually put it into some form of production. It could be limited production, but something that not only tests the software from their perspective, but also all of the support structure that goes around the software. Now, there are a couple of other forms of testing that might be appropriate. One is performance testing. So if you've got a really complex piece of software that's doing a lot of database calls and there's a lot of transmission of a lot of data between a phone and a host system or amongst a group of host systems, you've got concerns about utilization of bandwidth, communications errors that could occur in the midst of all that, recovery procedures if something goes wrong, but you're concerned about the response time to the user and the amount of time it takes to complete the functional requests that are made. So if you're concerned about that, you're worried about it because of the complexity of the software, you should do a performance test to make sure that this thing is humming along. The second one I call a usability test. You're going to get a lot of usability exposure, of course, when you do the beta test, but there are well-defined processes for testing usability into a product. And it can be done from the very early phases of design, where you can bring people into a laboratory kind of usability laboratory kind of a situation and actually run them through the screenshots back at UI, user interface design. So it's important, if usability is a concern, and it is important, you may want to do a special usability test as well. So you just should think about that. So I'm not done yet. There's one more thing. And that is support, customer support. Often, the product or the instance of its website that describes it needs some development work done. Of course, you need to develop a website where maybe all of your customer support exists. So you've got to accommodate the possibility of chat, either live or run by artificial intelligence software, automatically answering questions, a Q&A module of the frequently asked questions. Of course, the website itself, rich video content, particularly if you've got installation issues, for how to install a phone app, for example. Now that's all online stuff. You may also have phone kind of support. So you'll have if this is really complicated, you'll have a person devoted to all this, but it's got to be part of this overall picture of development. You're developing the support structure, and that takes a bunch of software as well. So that's it. That's all the stuff you got to worry about if you're going to take on a development project. You should decide which ones of these steps are most applicable to your project. The one I'm talking about here is a pretty elaborate process for a pretty sophisticated piece of software. You have something much smaller and much simpler. This won't take as long and won't be as complicated to get through. It can be done with smaller teams as well. So consider these, act upon them appropriately for your software project, but get this thing right, because once it gets out the door and it's got a bunch of bugs or it is missing the mark, and what you said you were going to deliver to in your functional spec that came from a lot of customer interaction, you're going to have some problems, some satisfaction problems, and you don't want that to occur. So with that, I see we got one question, but I think I might have answered it. So wait a minute, the question, I'm paraphrasing the question. It's, weren't all these customer requirements done by somebody else? Why is the developer doing that? Well, the answer is yes. It was probably done in market, a lot of it done in market research and the development of the marketing plan, for example, and the marketing survey work in particular that was done. But so that's a matter of the development team becoming familiar with all that, but it's got to go to the next step in laying out these customer requirements in specific terms that you'll write in your functional specification. So it's a reading and an understanding and getting clarification if it wasn't clear. Lots of times when you're presented a bunch of customer requirements, you've got a zillion questions you need to be asking the people that figured that out in the first place, so you really understand. The best developers are the ones that are enmeshed in understanding the customer and what their need is and how they would intend to use this product. So that's that question. Another question is over here. He said, what about MVPs? What about MVPs? That's the most important thing on the face of the earth. Well, I had it on my list. I just didn't talk about it. So let me talk about it now. Minimum viable product is a way to deliver a meaningful set of functionality, perhaps in limited form, particularly for the end user interaction, the benefits of getting that exposed to some early customers. So an MVP is, in my mind, a form of very early testing and to validate that you're on the right track. So yes, an MVP does fit into your thinking about your development process. Sorry I left it out. And that's it. I had 2 questions. So have a good evening. Hope this was helpful. Talk to you again next week. And again, my name is Bill Warner, and I'm with EntreDot. Have a great evening. Bye-bye.